Hello adventurers, and welcome to the last video for floor 10. In the first video, we worked with indexing and knows. In the second video, we worked with recall, has weakness, and count weakness. At this point, our self-test registry phases 1 through 5 are green. We have one stub left, which is forget, and it's the only method that touches more than one container. Then the whole payoff for the whole floor will occur. We can benchmark our names. You check out the standard libraries map find method versus our floor 9 BST's find method versus floor 1's linear scan. And the final takeaway will be that standard map is the balanced tree of floor 9.5 with a key value index bolted on for free. Forget is our consistency method here. We remove from the by name attribute, we decrement the weakness count. And the careful part here is if that count hits 0, the weakness is now extinct. So we need to erase it from both the counts map and the distinct weakness set, or we've left a phantom key style ghost, a weakness on the shelf that nothing has. That when it hits 0, erase both is really the lesson of today. Okay. Now, let's go ahead and let's build our executable and kind of see where we're at here to start off, just to kind of make sure we're on the same page. Okay. We'll do our self-test for our registry, and you see we're okay on these first 5, but we need to increment our forget here. Okay. So that is what we need to fix here today. Now let's go ahead and let's open up our registry header file here, if you don't have it open already. And let's find our forget stub, which should be down here towards the bottom. Yep, there it is, starting on line 186. And then what we need to do is, you see it takes a string there, a name, a constant name, and we're going to say auto iterator equals by name dot find the name. We'll say if the iterator equals the by name end, we will return back false. Otherwise, we're going to say const standard string w equals iterator. We'll grab the second weakness, and I'll say if we'll decrement our weakness counts of our w is equivalent to 0, then in that case we'll say weakness counts dot erase w, and we'll say weaknesses dot erase w. Then outside that we'll say return back true to me. Okay, so we need to first of all find the name here. If it's not there, there's nothing to do. So we return back false. That's the absence case that the test is going to check. Otherwise, we grab this monster's weakness before we erase the record. We'll need it in a second. And once the record's gone, we can't ask. Erase from the by name attribute by the iterator we already have. This is cheap. There's no second lookup. And then now for consistency, we have the decrement on weakness counts bracket W there. And what that does is it decrements the tally for that weakness. Okay. Here, the bracket is fine. W definitely exists in this case. We just looked its monster up. If that decrement brings the count to 0, the weakness is extinct. No beast has it anymore. So we erase it from the counts map and from the distinct weakness set. If we skip that, the shelf would keep a weakness with a 0 next to it, which would be the inverse of the phantom key, a ghost we failed to clean up, instead of one we accidentally made. And then we return true. And as always, the method is forget, but the command here is going to be called strike in our CLI tool. Floor 9's forget still removes from the BST. So, assuming you have that rocking okay, let's rebuild. And we're going to say self-test on the registry. looks like we still have a fail here. Oh, I noticed here, right after this line, I should add a line here for by name underscore dot erase it. There we go. Right after I find it, I can then erase it. Okay. So remember, once we go ahead, we grab the weakness there before we erase the record. So I forgot to do that, right? So we need to erase the record there. Okay. Now let's go ahead and build this one more time. Sorry about that. Now we're okay. Perfect. And then I can say strike goblin. We struck the goblin from the Hall of Names. 14 remain. Weakness fire. 5 monsters. Fear fire. Okay. We can recall the goblin. There we go. So what we can see here from this case is strike goblin removes the goblin from the registry. So then 14 remain. And weakness fire drops from 6 to 5 in that case. Because forget decremented fires count. Goblin has gone from the hall, but watch here when we recall the goblin, the floor 9 command on the BST, goblin is still there. That is not a bug. The bag, the BST, and the registry are 3 independent indexes over the same monster data. Forget touched only the registry. It never reached into the bag or the tree, and it shouldn't. If a student strikes a monster and then sees it in a list, or if you see it in list or recall and think something broke, that's the answer. There's 3 views, 1 source, free to disagree after you've changed one of them. That's not a flaw. It's just different tools doing different jobs. Real quick here too. Let me rerun this just to show you that the decrement worked appropriately. You'll notice here we have 6 monsters who fear fire. And this when we strike it, then we do weakness goblin. Or sorry, not weakness goblin. Weakness fire. You see, then it is decremented to 5. Okay, let's then run our benchmark on our names. We'll kind of compare what we've got going on here. So, what are we seeing here? This is really the whole floor on one screen. 3 ways to find a name in records. We have floor 1's linear scan, your floor 9 BST, and a standard map. And the map's built in line in the benchmark, so this command worked from day 1 regardless of your stubs. It's the comparison, not your code. Your microseconds will differ from mine. These are wall clock. They move run to run, so the numbers really here aren't as important, but the shape is important. The linear column climbs hard. At in 100,000, finding the last name can take hundreds of microseconds. It looks at every record. The BST and the standard map columns barely move, though. You're fractions of a microsecond at every size, because both find a name in about log of n steps. And look at the standard map column right next to the BST column. They track each other. The map is a balanced tree doing exactly what your BST did. And then watch the tree height column on the right too. 13, 21, 30, 40. As n grows, that's a log n climbing slowly, which is why the lookup stays flat. And then we can see what the program here prints underneath. That's the thesis of the associative run in the program's own words right here. Standard map matches the balanced tree, but you wrote one declaration, not a class. And unlike your plain BST, which became a stick the moment you fed it sorted input back on floor 9, standard map is a red-black tree. It can't degenerate ever. The library handed you the balanced tree of floor 9.5, the one you deliberately didn't finish, plus a key value index on top, finished and tested. You proved you understand the tree. Now you don't have to worry about writing one in the majority of circumstances. So, step back here at the whole arc. Floors 8 and 9 and 9.5, you built trees with your own hands and learned the hard way that a tree has to stay balanced and stay fast. This floor we stopped building and started using standard set for the names you need to know are present, standard map for the names whose meaning you need, and you got finished and for free the balanced tree you studied with a key value index on top. That recognition, understand the mechanism well enough to trust the library and reach for it, is a real engineering skill. But here the catch in the wind. The map answers any name by keeping every name in order, which means the library still walks the balanced tree, log in steps every single lookup. Fast, honest, and ordered. In the next hall, the names aren't in order at all. They're scattered on purpose, and yet each one answers in a single breath because the hall doesn't search for a name. It computes where the name lives and goes straight to it. No comparisons, no descent, O of 1, not O of log in, at the cost of order and at one new risk. What happens when two names compute to the same place? That's the word to carry down the staircase to the next floor with you. Collisions. The Hall of Whispers, hash tables, is next. McCown speaks one last name to the shelf and it answers, and he nods you toward the dark where the whispering starts. The bard does not damp the string. See you in the Hall of Whispers. Bye-bye now.